start PowerPoint on slide 1. Have you ever heard the saying that birds of the same flock together? This is true for many things. For people, businesses, types of food, they like to stick together. This is also true for minerals and chemicals in our kidneys. They like to stick together and form kidney stones. Please turn to slide 2. Harmful minerals in our urine and in our kidneys are like protesters at a riot. It only takes a few of them and they can stick together to create something much bigger, like a riot, or for minerals, a kidney stone. Kidney stones and protesters and riots all require mediators. The mediators for kidney stones are proteins called inhibitors, and the minerals for a riot are the policemen. They both need the same one to break them up. I have a heightened interest in kidney stones myself, higher than most people my age. I have had 6 different run-ins with kidney stones, all in varying types. I have passed them naturally, and I've also had to pass them through surgical methods. So my interest in these and my knowledge is something more complex than normal. Today I'm going to explain how kidney stones actually form. First, I'm going to explain the chemical makeup of the stones, which is essential to understanding how they actually form. The second thing I'm going to explain is how these stones actually do form in our kidneys. An essential part in understanding how kidney stones form is understanding what they are made of. Chemical makeup and minerals can vary. The stone can vary depending on what chemicals are in the stone. And their health communities explains how there is 5 different types of kidney stones. Please go to slide 3. The most common is the calcium stone. There's 2 different types of calcium stone, which are pictured in the slide. Calcium oxalate, which is the first picture, is calcium that is chemically formed to oxalate. And then the second most common calcium stone is calcium phosphate, which again is calcium just formed to phosphate. Pictured in the slide are the 2 different chemical makeups. All the different chemicals have to be present for these stones to form. The 2 pictures show the varying looks of them, just how those different chemicals make such a different stone. Now on slide 4 is a visual aid of all the types of stones, which I will explain and show you after I explain all the different types of stones. The third most common stone is a uric acid stone, which is actually the only stone that can be dissolved by an alkalizing medications which reduces the acidity. Uric acid stones are just those salts of the uric acid that form together. The 4th stone is struvite stones, which are a triple phosphate mineral stone. And the 5th one is cysteine stones. These are amino acid stones, but they're not like the uric acid and cannot be dissolved with just a prescription or anything like that. So now if you'll turn to slide 4, on the top is the 3 pictures. From left to right, the top one is the calcium oxalate, the second one is calcium phosphate, and the last one on the top is the uric acid stone. Now on the bottom from left to right, there is the struvite. The first 2 are both struvite stones. They can look very different because of the phosphate that binds in them. They can be very pokey and kind of different colors too. And the last one, which is the most rare type of stone, is a cysteine stone. Kidney stones also range in size from a fraction of an inch to several inches big. Now see slide 5. Very small stones that are 1/4 inch or 5 millimeters can pass naturally through your urinary tract with no to little pain. They normally go unnoticed. Stones bigger than that, bigger than the 1/4 inch or 5 millimeters, normally need surgical action to take them out, or they are extremely painful to pass them with medications. Now that we understand the chemical makeup and sizes of stones, we can move on to how they actually form. Please go to slide 6. Formation is complex and all things have to be present to make a stone form. Normal urine has soluble salts and minerals that is explained on uwhealth.org. These minerals are always in our urine. What causes a problem is when our urine is super saturated. So high concentrations of these minerals in our urine form the soluble salts to precipitate and create salts and go into a solid form. And once these salts and minerals are in solid form, they can attract to each other like protesters at a riot. They will just stick on each other and build and build and build from that point. Lack of inhibitors is another way or factor of how stones form. Please turn to slide 7. Inhibitors are proteins, and they kind of act like policemen at a riot. So the inhibitors in our urine are proteins that sort the soluble and mineral waste and pull them away from each other, keep them away from forming a stone. They can also attach to an already existing stone and break them up. When our urine does not have enough of these proteins, the stones will form, and that balance of too many of these minerals and harmful wastes and not enough inhibitor proteins will create the stone. Proteins, the inhibitor proteins are just a few, are citrate, magnesium, pyrophosphate, and phthalate. This is from uwhealth.org as well. Randall's plaques is another factor in stones forming in our kidneys. Please turn to slide 8. Randall's plaques act as binding sites for soluble salts. These sites are small calcifications that develop in kidney tissue, which is explained at kidneystoners.org. This calcification on our kidney tissue is very sticky, and they're often formed by trauma, but because they are so sticky, salts that are passing through the kidney that could go unnoticed hook to their jagged edges and build and build and build until they're noticeable and until they break off the kidney. The Randall's plaques are normally undetectable until after time enough of those salts that have been, soluble salts that have been precipitated into their form or their solid form, attach them and create a stone. So these plaques are like protester rallies. They are there and they don't cause a problem until more and more people come. So like a protester, the more protesters come, the bigger the event is going to be and the bigger the problem. Same with these Randall's plaques. The more salts that get stuck to them, the bigger they're going to be and the more of a problem it will be. These 3 different factors that I have explained are all essential to understanding how kidney stones form, as well as their makeup. Please turn to slide 9. In conclusion, today I have explained first the chemical makeup of kidney stones, the minerals and harmful chemicals and wastes that need to be present in a stone and how they make up the different types of stones. And second, I have explained 3 crucial ways and factors that stones can actually form in our kidneys. Like policemen and protesters, it's essential to have a healthy balance to prevent big rallies and to prevent kidney stones in our kidneys. Thank you for listening.